The third and final general class of question that we're going to have on exam 3 is that of molarity. And to understand how molarity fits into the grand scheme of things, you'll need to understand what a solution is. So recall, there are 4 states of matter. One of those was a homogeneous mixture. And a homogeneous mixture is also known as a solution. Well, what exactly is a solution? A solution is defined as the mixture of a solute and a solvent. It is a mixture. The bulk material is normally referred to as the solvent, and the minor component, the solute. For example, with a sodium chloride solution, the sodium chloride would be considered the solute, and water would be the solvent. Typically, water is going to be the solvent. Now, how does molarity fit into this? Well, molarity is a gauge of how concentrated the solution is. That is, how much solute is in the solvent. So we can have a salt solution, but it might be a very, very dilute salt solution, or it might be a very, very concentrated one. So we need a way to quantify that. And the way we're going to quantify it is by a concentration term known as molarity. Typically up to this point, when we express the concentration of a solution, we typically have been doing it as weight percent. But instead of talk about weight percent, we're going to talk about concentration in terms of molarity. So what is molarity? Molarity is defined as the moles of solute in a liter of solution. So if I have 1 liter of solution, it's how many moles of solute I have in there. As a quick aside, if you're ever given molarity in liters and you need to calculate the concentration of moles, then what you can do is use a very simple expression. MOL is equal to MOL. It's just a memory device where the dot that represents a multiply sign is substituted for the OL. So remember that. To calculate the number of moles, it's the molarity times the liters. That's just a rearrangement of that top equation. Okay, you're going to use one of those two if you solve an equation algebraically. What if you solve it by dimensional analysis, which I'm going to most of the time? Well, then we have to use the dimensions of the units. What are the units of molarity? It's moles of solute over liters of solution. There are 3 types of molarity problems that you're going to come across. 1, you're going to actually calculate M. That is, the question is going to say something like, what is the molarity if you have 16 moles of this in 2 liters of solution? Or it may say, calculate the molarity if you have so many grams of solute. That's the first type. The second type is when you're given molarity and you're asked to calculate something else. The key to this type is to write molarity as a conversion factor. And I'll show you how to do that. In other words, if you have something, let's say it gives you that the concentration of a solution is, the molarity is equal to 8, you have to rewrite that. There's 8 moles for every 1 liter. The third type are probably the easiest ones. Those are called concentration dilution problems. And you're going to see that the molarity times the volume of a solution before you concentrate it or dilute it with solvent is going to be equal to the molarity times the volume after you concentrate it or dilute it. So what we'll do now is we'll work through at least one of each type of these. Okay, let's look at a sample problem. Calculate the molarity for a solution made when 0.1 moles of HCl is mixed with enough water to make a 2-liter solution. First, let's envision what's happening. We're taking 0.1 moles of HCl And we're combining that with enough water so that we can make a solution that is exactly 2.00 liters. Pour in some of this, pour in some of that, top it up to 2 liters. That's what we want. The question now is, how concentrated is that material? Slightly, moderately, or a lot? Well, first of all, let's calculate that. Which type of problem is it? Well, it's going to be what? A type 1. Why? Because we're calculating molarity from a given amount of grams or moles. And you can see with the box here, what are we calculating? Molarity. That's always my box. In my box equals star type of logic. For a solution made when 0.1 moles of HCl, there's my star. That's the only thing it gives me. So that tells me I'm going to calculate molarity from moles. Okay, so if it's type 1, now I know this. This formula always works for these type 1 molarity problems. Dimensional analysis. Now, it's box equals star, but in this case, I have a box in the numerator and denominator. Why? Because in this case, my unit for molarity has a term in the numerator and a term in the denominator. So, but I'm still going to use my box equals star analogy. So this says, calculate the molarity starting with what? 0.1 moles of HCl. I'm going to put that over 1 because that's a given value. Okay, now what do I have to do? I've got to keep adding conversion factors and given data to the right until the units work out exactly right. Okay, so what do I need to do now? I already have moles, so that's easy. I need moles to show up in the numerator. And the problem actually told me how many moles. And now what do I need to show up in the bottom? I need some volume of material. So let's see what we have here. Oh, I was given a volume, wasn't I? 2 liters of solution. So I'm going to write this down in the denominator. Why did I write it down in the denominator? Most of you know because I need liters to show up in the denominator, and I had a given value which I could do that. And now I just pick up my calculator and punch out the numbers, 0.1 divided by 2.00, and come up with my final answer. So looking at a cleaned up version of this, we can see I have 0.1 moles divided by 2.00 liters is equal to, oops, sig figs is wrong. It should just be 0.5, 0.5. Why? That's only good to 1 sig fig, so my answer can only be good to 1 sig fig. So my answer is I'm going to put a label on my solution that says 0.5 molar, and I have it. Okay, let's look at a similar problem. Calculate the molarity for a solution of 3.65 grams of HCl. Well, I recognize this as a type 1. Why? Because it's asking me for molarity and it's giving me grams or moles of something else. So I'm going to immediately go to how many moles of HCl, I know what my solute is, are there in how many liters of solution. Okay, do I know any of these? Yes, I do. I actually know how many liters of solution. I'm going to put that in the bottom because I'm looking for liters and I have liters. Yes. And now what do I need? I need moles in the top. I don't know moles, but I do know grams. 3.65 grams, which I can then convert from gram to moles after calculating the molar mass of HCl. 1 mole equals 36.5 grams. That's the weight of 1 HCl plus the weight of 1 hydrogen. And then when you multiply that out, you get 0.5 moles per liter, which is the same thing as 0.5 molar. That's your concentration. Just to confirm, grams went away. It needed to go away because it's not in my answer. Moles showed up in the numerator like it's supposed to, and liters showed up in the denominator. I have the right units. That must be correct.